Dear students, we are in the eighth part of the continuation of biomechanics of elbow complex. So to complete the last class slide, McGuane and Bookout conducted an investigation or study to understand the effects of articular fluid on range of motion. So articular fluid normally they are present to enhance the range of motion between in any synovial joint. So they have found that the flexion arc of motion decreases 2.5 degrees per millimeter of injected fluid means normally very less amount. For example, I can give you an example of the largest synovial joint, which is knee joint, and the knee joint has approximately 5 to 6 ml of synovial fluid. 5 to 6 ml, that is very comparatively very less synovial fluid. It's just like a layer to prevent friction. So here when the like any kind of swelling, so here artificially when we inject fluid into the articular space or in the synovial space, so every millimeter of fluid injected excessively decreases 2 degrees. 2.1 means 2 degrees of range of motion. So if 10 millimeter is injected, what will happen? 20 degrees of range of motion is decreasing. They conducted this study to prove that when swelling is there, why there is decrease in range of motion. The same synovial fluid, which is important and necessary for increasing or maintaining range of motion by decreasing friction between the articular surfaces. Whenever the synovial fluid increases, when only they increase during pathological inflammatory conditions or any kind of edematous condition. So in those conditions, this study helps us to understand that every millimeter of actually it is milliliter actually. So I want to correct it. Maybe the book it says some error in the thing. So milli a liter of the fluid injected decreases 2 degrees of range of motion. The bony components provide half of the resistance to varus stress in full extension. So the body component only provide 50% of resistance to varus stress, means stress towards the medial side. The stress which moves the or pushes the radius and ulna towards the midline is the bony component has lesser role to play, and the lateral collateral complex, which we have studied earlier, which includes the lateral collateral ligament and the lateral ulnar collateral ligament, and the joint capsules provide the other half. So we can say the resistance to varus stress, the counter action to varus, or resistance to varus stress in full extension. You have to remember this is in full extension and is provided 50% by the bony components and 50% by the lateral collateral complex and the joint capsule. Resistance to joint distraction in the extended position is provided entirely by soft tissue structure. The distractive forces, longitudinal forces that distract or separate the humerus from the radius and ulna is purely the counteracting force or the resistance is provided by the soft tissue structures, means namely ligaments and mostly the muscles, which are playing an important role here and very less role played by the body. Approximation of coronoid process with the coronoid fossa and of the rim of the radial head in the radial fossa limits extremes of flexion. We have already discussed that, so nothing more to explain. In 90 degrees of flexion, the anterior part of the medial collateral ligament, here you have to remember it is in the exact midway of the range of motion of elbow flexion, that is 90 degree of flexion. The anterior part of the medial collateral ligament provides the primary resistance to both distraction and valgus stress. So here in extension we have understood that the resistance is purely in extended position in the joint distraction or longitudinal destructive force is only by soft tissue, but during flexion of 90-degree we can see that the distraction is resisted by anterior part of the medial collateral ligament. If the anterior portion of the medial collateral ligament becomes lax, what is happening? So here both longitudinal distraction as well as valgus stress. Here we talked about the varus stress. So here the valgus stress, that is outward lateral stress, and the longitudinal distractive stress is counteracted by medial collateral ligament, which is the anterior part of the medial collateral ligament in 90 degrees of flexion of elbow. If the anterior portion of the medial, so this what we are talking about, the anterior portion of the medial collateral ligament becomes lax when becomes loose, overstretched. But usually lax means overstretched. Through overstretching, through repetitive stress or stretching, the medial instability will result. What through overstretching, medial stability will result when the elbow is in flexed position. So because of this valgus, so medial collateral ligament anterior part gives resistance to distraction as well as valgus stress. So what will happen when this ligament is affected? Medial instability will affect in flexed position. Also the carrying angle will increase. Naturally it will increase the valgus angle. The cubitus valgus will increase, so naturally it will increase the carrying angle. The majority of the resistance to varus stress when the elbow is flexed to 90-degree is provided by, so we already discussed about what the contraction of valgus stress here. So varus stress is purely in the 50-degree flexion is provided by the bony structures of the joint, and only slight amount lateral collateral ligament and the joint capsule, the lateral ligament and complex provides only very less stability for counteracting varus stress. So we are going to the muscle action. We have almost gone through the functional aspect of the that is a range of motion we have gone through, and in each range of motion, because in elbow joint, because of the loose hinge variety of synovial joint, there are much changes in the flexion, range and extension. We have discussed that regarding the range of motion, biomechanics of that. Now we are into the muscle action, that's the function of the muscle. This is also very important. So here, before going, we will see the summary of the factors. Many factors are affecting the muscle action on the elbow, muscle activity on the elbow joint. So we have given it in like using bullets, highlighted the important factor. The role that the elbow muscles play in motion at the elbow is determined by a number of factors, including, what are those factors? Number one, number of joints crossed by the muscle, whether it is one joint or multi-joint muscle. So, so one joint means a muscle crossing single joint. Two joint muscle or multi-joint means muscles crossing more than one joint. So the when we are discussing about a particular muscle in elbow joint or elsewhere also, the importance is first you have to remember that is the muscle a single joint muscle or a two joint muscle. If it is a two joint muscle, you all are very well aware that insufficiencies such as passive and active insufficiency will play a role. So number of joints crossed by the muscle is a very important factor when we consider the action, muscle action on the particular joint. Here we are talking about elbow joint. But this is and here next point, this first point is common for any synovial joint. Second point also is common, physiological cross-sectional area, or short form we call it as PCSA, physiological, that is regarding the cross-section area means the bulk of the muscle. In which area, where, what is the bulk of the muscle? The bulk of the muscle dictates the function of the joint, particular range of what biomechanics of the joint. So physiological cross-section area, which is also common for other joints. Location in relation to joint. What is the location of the muscle in relation to the joint? Whether the muscle is located anteriorly, obliquely, posteriorly or posterior obliquely, laterally or medially, all this, or whether it is intracapsular, or extracapsular, all these things. That is the location of the muscle in relation to joint is very very important. Position of the elbow and adjacent joints. What is here we are talking about, all the other factors are common for any joint, but now we are coming to elbow joint, specifically to the elbow joint. So the positions of the elbow and adjacent joint. So here adjacent joint is very very important, because we have already discussed that elbow joints, the biomechanics of elbow joint depends upon the, earlier we have discussed that factors. Range of motion is dependent upon shoulder, radio, that is your what you call as the radio ulnar joint, superior and inferior radio ulnar joint, that is called as another adjacent joint, and also wrist and finger joints. Position of the forearm. So position of the forearm means whether the forearm is in supination or in pronation or mid prone or mid supine position. So these positions we don't call mid supine, we only have mid prone and supine and then prone. So these positions of the forearm may also play a role of the on the action of the muscle on elbow joint. Magnitude of applied load. What is the magnitude or the size? We can, size means how large is the, whether it is larger load or a smaller load. So the size of the load, the magnitude has to be specific of the load is very very important, whether the what action the muscle will play on elbow joint. We, as you all have studied the types of muscle action, here also the types of muscle actions commonly seen: concentric, then eccentric, isometric and isokinetic. These three type of muscle, what type of muscle action will play a significant role in determining the elbow muscle joint activity. Speed of the motion, we already know that there are two types of muscles fibers are there: slow and fast acting muscle fibers, and what we call as the red and the white muscle fibers. So the speed of the motion of the muscle fibers and also the type of the muscle fiber, as we call it as, it is coming in the last factor, fiber types. So speed of the motion here, whether the speed is slow or whether it is fast. This speed will also determine the type of muscle action acting on the elbow joint activity. We all know that the momentum, or the, what is a momentum? It is the distance between, perpendicular distance between the axis and the action line of the muscle. So whenever we know that whenever the perpendicular distance between the joint axis and the action line of the muscle increases, the momentum increases. Whenever the momentum increases, the rotational force is called as torque. So angular rotational force increases, that means that the torque increases. So when the momentum increases, torque increases, means power of the muscle increases, or the effect of the muscle increases. The momentum decreases, that is MA decreases, whenever the perpendicular distance between the joint axis and the action line of the muscle decreases, the angular rotational force, that is a torque, decreases. So momentum also plays an important role. Then the last point here is, all the points are very very important. So the fiber types, you know that we are talking about the muscle fiber types. So you know the slow oxidating fibers, the that is called as the red muscles, and then you have the fast glycolytic, all the various types of fibers classification which we have studied in the third chapter. We have to remember here. So these factors, my dear students, we have to remember very clearly. These factors, the above 1, 2, 3, and three factors, and the fiber types, muscle fiber types, the momentum, the type of the muscle. So here, except the position of the elbow joint, position of forearm,